Now it's time to take a look at the ocean and how we can initialize the world and predict the behavior that we'd like for the ocean class itself. So to do that, we're going to have to go and edit its code. And so far all we've done is built the world. Now we have to think about initializing it, and that always happens in the constructor, right when the world is built. So when it's built, I need to have the submarine in the world as well as put the shark in, so that way the game is ready to be played. So down here, that's what I'm going to do, is create my submarine. And now I have to add it to the world. So I'm going to put it dead center in the screen, and that'll be, since it's 450 wide, since it's 900 wide, it'll be 450 where I would like it to be. And the height is a little trickier. The top of the screen would be 0, but that would mean the center of the sub would be at the top, so part of it would be off the screen. So what I'm going to do is bump it down by half of the width. That way it'll be exactly at the top. So half of it, if it's the submarine that I need to know how tall it is, I will get the image from the sub, get its height, and half of it should get me to where I need to be. So we can compile it to see what it looks like here. And there it is exactly at the top because the center's here and I had to bump it down by exactly half like that. Okay, so I'll put my code back up. I'm going to do the same thing with the shark now. So the shark I'm going to call the player, since that's what it'll represent. And I have to add it to the world. And I'm going to put it just right in the middle of the screen. So being 900 by 500, that means I'm going to be 450 and 250. Now, I'm not too thrilled about the fact that I put these numbers in here like hard-coded as 450 and 250. I could ask the ocean how wide it is simply by doing this dot get width and then divide it in half. That'd be much more versatile because then if I ever made any changes here, it would already be reflected down here in the method call. So I'm not super happy about the fact that I've got that there, but anyway, for the purposes of this example, that should be okay for where we're at now. So now if I compile, I actually have a shark and a submarine. So I can run my game for a little bit here. It's going to drop submarines, or torpedoes rather, after me. And when I get hit, well, then the shark disappears. So we have to do add one other thing here to this behavior, and that's the behavior of the world. We need to start getting fish appearing in the world, or there'll be nothing for the shark to eat. So I'm going to override the act method. The ocean class has an act method because the world does. So if we open up documentation here, you can take a look at the methods that are available to you. Since ocean's a subclass of world, all of these things are available to you. If you don't want to use them the way they've already been done, you can override them. And that's what we're going to do with act here. We don't want to use the parent's act. We're going to overwrite it with our own. So in my code, I'm going to go down here and put public void act so that Java knows I'm rewriting the way the world behaves. So as I mentioned, what I'm going to be doing is adding fish to the world. So we can start by creating a fish. And of course we're going to need to put it into the world as well. So I need some coordinates for it. So what I'm going to have happen is the fish are going to start on, let's take a look at the world, the fish are going to start on this side of the world and swim across for the shark to eat. So over here, that's going to be 0 for the x coordinate. But the y coordinate, it's 500 tall, so I think I'm going to make it maybe from 100 to 400. They'll randomly appear somewhere in here, the fish. So let's go back to Greenfoot. So let me see here, my random y coordinate is going to be equal to math.random. And again, if I'm going from 100 to 400, then I'm going to need, if you think about how many values there are there, there's 301 values. I guess we can, 301, because I'll give a quick explanation. So from 400 minus 100, that's 300 values, but because we include the first value, we have to add it as well, so it would be 301. And because I started 100, I'll have to shift everybody up by 100. So I'll maybe make a comment here that this is the values from 100 to 400 when I'm done. Okay. Now for the x coordinate, I did say I want it to start at the left side. And we could think of that as 0, but remember the fish, that's the center of the fish then. It's going to be chopped off when it swims in. So if we wanted to advance the fish a little bit forward, what we'd have to do is get the fish's image and get its width divided by 2. And remember, because I'm doing integer divisions there, I could end up losing a bit, so you could put a little bit of a buffer there just to make sure it's completely on screen when it's put in. It's not necessary. I mean, you could have the fish coming in partially when it starts, but I'm going to leave it like this so that way I'm able to see the whole thing when it's put in. Maybe I'll just call it X. So now I need to add the object, which is F to the X coordinate and a random Y. And then we're going to be able to run this and see what happens. Now it's not going to probably act the way maybe you can predict, but it's not going to act the way we want it to right now. So let's run it and see what happens. So I hope the shark is hungry because, man, there's lots of fish to eat here. So the problem is that every time act is called, another fish is put on, and we don't want that behavior. There's just way too many here. So we're going to restrict how many fish are able to... we're not even getting torpedoes, I think, because they're probably blocked. Oh, there they go. Now they're hitting some fish too. But anyways, we probably want to slow down how many fish we're using here. So let's go back to where we were. Open up my code. And the way I'm going to deal with it is I don't want every time the act method is called, I don't want a fish to appear every time. I only want it to appear certain times. So what I'm going to do is I'm going to give the ocean a counter here. So I don't want everybody to have access to this. I'll call it private int. We'll call it act counter. Now when the game starts, it hasn't acted yet. So we're going to initialize it to 0 here when the world begins. And then what I'm going to do is keep track of it inside the act method. So down here, every time act is called, I'll increment it. But I need something to compare it against. So we need some sort of threshold. Oh, sorry, that should say counter. If I could spell, there we go. We need some sort of threshold to compare it against because we don't want this to happen every time. What we're going to do is we're going to put an if statement in here. And, maybe it's 100 that we're going to do for our threshold. So basically what we'll say is if you get up to 100, then it's your turn. You've waited 100 times before you've done this. So now you can add the fish to the world. Then of course we want to restart the counter. So we go back to act counter, reset it to 0. So this should run more or less the way we expect, but I don't like the fact that I've just got this number hanging out. So I'm going to define a constant for it. So I'll make it private, and static is a keyword in Java that means everybody can share this variable. So that way, if there was more than one ocean being used in my game, they would all refer to the same value here. It's just a way of saving space. The act counter, however, needs to be unique because each world might be acting a different amount of times. But anyways, private static int, and we're going to call it, how about fish timer? And I'll set it to be 150. I've done a little bit of experimenting, and that time at 150 seems about reasonable for what I was looking at. So in here, I'll call it fish timer. I should probably also make this a constant. So we'll jump in here and tell Java that's also not changeable, so no one could mess with it. And again, that way I know that anybody using this variable is going to have the same timer, and anyone can access it that's a member of the class, but there'll only be one shared copy in memory, so I don't waste too much space. So why don't we compile it now, and we'll run it and see what happens with the fish. So it's running now, and there's a fish, another fish. So something about like that, that's probably a decent speed for the fish to be appearing, but they should be appearing at regular times every 150 act methods that are called. So anyways, stop playing my game and I'll let you guys mess around with it.